Here's the AutoCAD model that we used to model the machine. And you can see that part number 1 is a cylindrical barrel that's made out of plastic. Number 2 is the filter. 3 is the lid. 4 is the drain plug. 5 is the rim. 6 is the tire. And 8 is the sheet metal frame. And number 9 is the handle. 10 is the soap dispenser, and actually 10 is the bracket. 7 is the soap dispenser, and number 11 is the water container that we're going to use to hold extra filtered water.
Within the process, we need to analyze what machines we're going to use for what parts. The cylindrical barrel, we're going to use an injection molding machine. I thought that would be very easy because you can probably pour the material into the machine and it can mold it within the mold very quickly and very efficiently. Assembling the washing machine, we're going to use an ultrasonic welder. We're going to fuse the plastics together. And again, this is going to eliminate bolts and screws. Rubber tires and rims, they are going to be, we're going to be using, if we're going to be using them, an aluminum extrusion machine, an aluminum bending machine, an aluminum rim welding machine, a case sealing machine, and tire rolling machine. The soap dispenser and drain plug, we will also be using an injection molding machine. The filter, we're not going to be making a filter. We think that we would need to hire more people and more expertise to make the filter. Extendable handle, and we're going to be using a roll form machine. And the bearings, they're very small, so we thought that we could buy those at a very cheap price, and that will save investments in machines to make those.
Go. Some of the major and essential components of our product which we had to define if we were going to make or buy include the following: the filter, the cylindrical barrel, the wheels and the tires, and the frame. Starting off, we decided to right away buy the filters because they require a lot of experience and a lot of skill, and it's a specific product which can't be easily produced and manufactured. Therefore, we just decide right away to buy this product, and then we focus on doing a make or buy analysis of the frame, of the wheels and the tires. And as we can see in our next slide, some of the costs of the wheels and tires include all the machines required, and they yield a total fixed cost of $334,000, as we can see, and the variable costs are $661,000, but this is for a 25,000 batch. And another contractor is willing to sell us the wheels and the tires for $425,000 for a $25,000 batch. And therefore, we have made this analysis, as we can see in the graph. It's easier and cheaper to buy the tires than to make them, and therefore we have decided to buy the tires. Then, following this analysis, we decided to do a make or buy analysis of the frame, and as we can see, the fixed cost of the frame include $25,000 for a roll forming machine, and the variable costs are $3.76 per unit for this same frame, and this includes the materials, the labor, and the maintenance. And another contractor is offering to sell us the same product, the same frame, for double the price, $6.84. And as we can see, it starts off cheaper to buy, but considering our production, our break-even point is way below our demand. Therefore, it's recommended to make this product, and we have decided to make the product. And the last product we decided to do a make-or-buy analysis on is our cylindrical barrel. This is one of the biggest component and requires the most material. But considering that we would have a fixed cost of $150,000 and a variable cost of $2.25 per unit, this results in a better and more cheaper alternative compared to what our offerer and contractor is willing to sell us a barrel for, which is $27 per barrel. And we can see the huge difference in the following table of how it is cheaper to make it than to buy it.
So in order to talk about our process and the reason behind our process, I think we should first go into all the different tasks. So we wrote a list of all the 15 tasks that need to be done to create our portable washing machine. The first task is to mold the cylindrical barrel. This is done by the plastic injection machine, and this is going to mold it to have a lid and also a drain plug. So after this is done, then we have to have an inspection of this to make sure that it came out of the mold properly. If we waited to inspect till the end, we might have to send it all the way back rather than getting rid of the ones and not having to waste other parts later down the line. So our third task is to assemble the filter to the barrel opening. We're going to put the filter to filter the water inside of the barrel, so that's done after the barrel is created. Then we have to assemble the wheels, so we're buying the rims separately from the rubber that's going to go out on the outside of them, so we need to connect those. That's our next step. And the next task after that is to attach the wheels to the barrel by screwing them on. Then we have to attach the bearings to the outside of the rims so that we can eventually attach our frame onto that. So we need to attach those bearings. So we have the bearings, the wheels, and then we have the barrel so far. Our next step after that is to create the frame using the roll forming machine. This is going to create the handle that we're going to be used to roll the cart. After this is another inspection, because as we talked about earlier, if we inspect the frame right after it comes out of the machine, this will save time later in the process rather than realizing these errors after we've already connected it maybe to the rest of our barrel. The next step, we have to attach the grip to the top of the handle. This is going to be a rubber grip that can be put over it so people can push it more easily and it will go better on their hands. Then we have to seal the frame edges to the center of the wheel. This is connecting the entire thing into one unit. After that, we're going to mold the storage tank of water so they can have extra water when they get done cleaning, and we're also going to mold the soap dispenser. That's going to be using the plastic injection machine as well. So after that, we're going to do one more inspection to make sure those come out fine. We're going to attach the brackets to the frame. These are going to be used to hold on the storage, the water storage, and the soap dispenser. Can we go back to that side? And our next step, we're just going to attach the dispenser and the water storage on it. And finally, we're going to do a big final inspection, and this will make sure that everything is right and connected fine. Okay, this is just going to go more into the reasoning of our process, why we're having it the way we've had it set up. We need to have it set up this way. If you go back and remember what we talked about for DFM, you want everything to start at the base. You want to have something at the bottom that's a base that everything else can be attached to and built off of. In this case, it's our barrel. So we're going to have the barrel, and then we'll attach the wheels, we'll attach the frame to that, and then eventually attach the smaller. So as you can see in the top left-hand corner is where we start with the molding of the injection barrel. This is most important because, like I just talked about, it's the frame. We also want to make sure that we don't have bottlenecks. We want to make sure that everything's parallel and our workstations aren't overlapping. If we have cycle times that are too far off or anything, everything won't be parallel, and we're going to have things that get stuck, and it's going to add time and waste time that we could be making more products. On our next slide, we've written out the tasks in a horizontal fashion just to show how they connect to each other. Using this, we can put them into different workstations. We want to have the closest cycle times as possible so that we don't have a lot of overlapping. This slide shows the 5 workstations that we put them in. Our cycle time for this process is 1.75 minutes, so 1 minute and 45 seconds. This is because that's how long it takes the first step to happen, the molding of the barrel. This is our longest step. So everything else can happen in less time than that. So we have these 5 stations that have different cycle times, but they're all relatively close. Our smallest one is only 1.1 minutes, so they're not too far off. So this is just why we've done this process, just to decrease bottlenecks, to increase productivity.
Okay, as you guys can see, these are our workstations, which we already described and talked about previously. And now we're going to perform and create a simulation out of these workstations and our assembly lines on Simio.
As you can see, we have sources at each leading entry of Workstation 1, Workstation 3, and Workstation 4. When the material goes through Workstation 1, it passes through an inspection. If the part that has been manufactured in Workstation 1 does not meet the standards, it goes back up and through and back down to the beginning of Workstation 1 to be resent through and to meet the standards for quality. Meanwhile, the whole system is running, and there are material going through source 3 into Workstation 3, Workstation 4, and Workstation 1 all at the same time. This whole system is running at the same time. And it all meets down into Workstation 5, and then it is going to go through to a final inspection, where, again, if it does not meet the standards, it goes back up through, and then we're through Workstation 5 again, and then works through into the sink. The processing time, as you can see, from Workstation 5, there is an average task time of 1.2 minutes.
And now we're going to run our simulation and see what inferences we can make out of these. And as you guys can see, our simulation is running. And we can see some queuing in Workstation 2. Also some building up in Workstation 1, a little bit in Workstation 3. But overall, our process is going rather quickly with no drastic queuing, and we're gonna accelerate our process to 150. And now we can see that Workstation 2 has definitely some queuing, which would need to maybe be enhanced or be looked at. If there's too much of a production at a given moment, there might be some problems in Workstation 2. But overall, our process is rather good, and we can see our results. You can see our process results here, and as we can see, it shows us the average total of the conveyors.
We can see queues, flow times, for each conveyor. If they all describe the same content.
And as we can see, like, some of the inference we can make out of these is that we can see which points are our critical points. And overall, we learned that our process definitely queues in Workstation 2 after a lot of production, and there's a possibility of Workstation 5 queuing in the future, as there's 3 production and conveyors meeting into Workstation 5.
Which could build a queue.
And this is what we can conclude out of our Simio.
Yeah.